This is section 3.4, graphs of polynomial functions, day 1. So when you look at the graph of a polynomial function, you should notice that it is a smooth, continuous curve. You're not going to have any sharp corners, and you can draw it with one stroke of a pencil. Okay, you're never going to have to pick up your pencil to start at a different piece. It should just all be one continuous, smooth piece. So we kind of talked about it a little bit in the last lesson about using factoring to find zeros of polynomial functions. So we want to factor each part, or factor each function and set each part equal to 0, and that tells us what our zeros or our x-intercepts are. So if we look at this first one, f of x equals x to the 6th minus 3x to the 4th plus 2x squared. What we're going to do is the first rule of factoring says take out anything that they all have in common, which in this case is x squared. So we're left with x to the 4th minus 3x squared plus 2. And then I'm going to factor that second piece. So we have x squared, and then x squared minus 2, and x squared minus 1. Take each of those pieces and set it equal to 0. So x squared equals 0. X squared minus 2 equals 0, and x squared minus 1 equals 0. In this, x is equal to 0, but since we can't do plus or minus, we call this a double root because it technically counts twice. Over here, add your 2, x squared equals 2, so x is equal to plus or minus the square root of 2. So remember, when you do a square root, you need to do plus or minus. Same thing on this one. X squared is 1, so x is equal to plus or minus 1, because the square root of 1 is 1. Notice that the degree of this function is 6, and we have 1, 2, 3, 4, 5, 6 answers. That should work out pretty well there. Let's look at that third example here quickly. On that third example, so we have g of x equals x minus 2 squared times 2x plus 3. If we were to FOIL this out, we find that our degree is equal to 3, so we should be getting 3 answers. So so notice that we could rewrite this as x minus 2, and then 2x plus 3. Because when we say squared, we mean write it twice. So x minus 2 is equal to 0, x minus 2 is equal to 0, and 2x plus 3 is equal to 0. You get that x equals 2 in the first two cases, and then x equals negative 3 halves in the third case. Once again, you're going to see that this doubles up, so this is a double root. So we have 1, 2, 3, matches our degree, so we are good. So to find zeros with a graphing calculator, you're going to type the equation into the y equals page, adjust your window so you can see the graph, and then there's a second calc. So second calc is above the trace. So second calc, and then trying to find a 0. What you're going to do is that you're going to use, so if your graph looks something like this on your graphing calculator, if I'm trying to find this 0 right here, it's going to ask for a left bound, so I'm going to scroll and I'm going to find any piece or any point that's on this piece, and I'm going to click on that and hit enter. Then it's going to ask for a right bound, so I'm going to click on any point to the right of it that hasn't yet crossed the x-axis again, so I'm going to click right here. And then if you hit enter again, it'll give you your 0. Then you would just repeat the process over here using a left bound and a right bound. And same thing for this one with a left bound and a right bound. So sometimes you won't get as many zeros as the degree says there should be. This is for one of two reasons. The first reason is that there are imaginary zeros. So back when you studied quadratic functions in Algebra 2, you learned that quadratic functions could be sitting up here and that it never crosses the x-axis, which meant that we had two imaginary zeros. Okay, that's possible in other polynomial functions as well. It's just not going to look the same. Or we could have multiplicities. So let's look at the original parent function for x squared. Okay, it looks something like this. Notice that the only time it hits the x-axis is here at 0, and it looks like it hits it and bounces right back off. That's because we have multiplicity. So remember, when we have x squared equals 0, we said 0 was a double root. That's what it means when it bounces off. That means that it could be a double root or a quadruple root. Okay, so anything that bounces off has an even multiplicity. And then if we look at the graph of the cubic function, so it goes like this. Okay, so this is x cubed. Same thing, we only have 1 0, but we should have 3. So it looks like it slows down and then picks back up again after it crosses. That's called a triple root. In this case, it's a triple. It could also be a 5th root, 7th root, as long as it's an odd. Okay, so even ones look like they bounce off. Odd ones look like they come close, they slow down, and then they pick it back up again. So we want to identify the zeros of this function and their multiplicities if the degree of the function is 6. So if the degree of the function is 6, that means we should have 6 zeros. So I'm going to go through and I'm going to look on the graph, and I see one of them here, one of them here, and one of them here. So looking at that one on the left, our 0 is at x equals -3. The second one is at x equals -1, and the third one is at x equals 4. So we only have 3 times that this function crosses the x-axis, but we know that there are 6 zeros. So we have to figure out odd multiplicities, even multiplicities, or what we have going on here so that we get a total of 6. Well, the first one, I'm going to look at this x equals -1. So notice that it just goes straight through, kind of like normal. So this is only a single root. So that one is fine. It looks normal. Looking at this first one, it comes down and it bounces back off. That means it's an even multiplicity. And this other one slows down and then speeds back up again. So we know that that's odd. So we need to find an even number that if we add it to 1 and then add it to an odd number, we should get 6. Well, I'm going to start with just a basic even number, so I'm going to say 2. If that's 2, in order for this to work, this would have to be 3, which works out because 3 is odd and 2 is even. So we're going to say that x equals -3 is a double root, x equals -1 is a single root, and that x equals 4 is a triple root.